already know, because you have been subtracting since the first grade, maybe even a little bit in kindergarten. What do we know about subtraction? Good. We know that that's the symbol of subtraction. Great. What else do we know about subtraction? Eliana, what do you know?
That subtraction is taking away.
Ooh, I love that language. I'm going to put it in quotation marks because it's like a phrase. When we are subtracting, we're taking away. I like it. I like it. Ethan, what do we know about subtraction?
I know that it would, if you're subtracting, it would be whole.
Ooh, can you explain that a little bit more?
So if we were subtracting, we would actually have the whole at the beginning, and one part in the middle, and the other part at the end, and we would have to figure out the last part.
I love that. So when we are subtracting, we're going to talk about this today, Easton. When we're subtracting, we are going to start with the whole, aka the total amount of things. Start with the whole or the total. That makes sense. If I want to know, I have so many pencils in my room, and then I take away the broken ones, in order to even figure out how many pencils I had sharp, I need to know how many pencils I had total before I can start taking things away. I don't just start with one pencil and then take away 16 pencils. That doesn't even make sense. That would be crazy town is what it would be, definitely. Emma, Scarlett, what do you know about subtraction?
Addition is adding. Subtraction is taking all of the numbers that we have. You have 10 minus 7, and you take away 7, it's not worth it.
Can you say that one more time?
The subtraction is taking away things, and addition is adding things.
Okay.
And if you have 10 minus 7, you take away 7, it's not worth it.
Okay. So there is a relationship with addition. Which we will also talk about when we start looking at part whole. There's this idea that subtraction and addition are very similar to each other. Very similar to the idea that we've already done with multiplication and division. Those two are very similar to each other. Addition and subtraction are going to have the same kind of relationship. Emma? All right. So let's talk about what subtraction looks like, specifically on a number line. That's one of the first ways that we learned how to do subtraction. And that's where subtraction really lives, in that number line world. So on your notebook, go ahead and draw a number line. And we're going to do the very easy equation of 7 minus 3.
That's a 4.
Sorry, 7 minus 4. Sorry.
What?
Sorry.
You just put...
That's fine. You can't do that. We got bigger issues. Alright, so when we are subtracting, these two numbers that we see are going to be our endpoints. So I know that the 4 is going to be the smallest number. It's going to start at the beginning. And the 7 is my ending number. It's going to be at the other end. So I have a number line now that is going from 4 to 7. We also know that when we are doing anything on the number line, I'm not counting spaces, I can count my jumps, right? How many jumps is it going to take to get from 4 to 7? It's a good question. So Dominic said, well, what about 7 to 4? It should take the same amount of jumps, right? I'm going to go the same amount of hops to get to 4 as I am to get from 4 to go to 7. This subtraction that I'm doing here, the answer is called a difference. How many of you have heard that? Raise your hand if you've heard that a subtraction answer is called a difference. Does anybody know why? Arwen, why?
Because it's like different from all the other numbers, and it's like the sum, and it's not the same. And then you just minus everything, and then now you still have the number.
Nope. What do you think, Ethan?
I think it means, like, if you have 4 plus 7, 4 minus 7.
Nope.
7 minus 4.
Yep.
It would be 3, but if you switch those around, because subtraction doesn't have the commutative property, it won't equal the same thing. So 4 minus 7 would equal something negative.
Okay, so why is that called the difference?
Because the answer will be different.
No, every answer that you do is going to be different. The reason it's called the difference is it's because subtraction measures the distance or the difference between two numbers. That's what subtraction is measuring. Let's go ahead and write that down under our number line. Subtraction measures the difference. I like to use the word distance because I like to think in terms of a number line, the distance in between my two numbers. So again, subtraction is just counting the number of hops in between two endpoints. That's what it is measuring. That's what difference is. That's what distance is. That is what that is. So let's continue on. How many jumps? We can go forwards or backwards because we have our two numbers. How many jumps is it going to take to get from 7 to 4 or 4 to 7, however you want to think about it? How many jumps? Arwen? 3. Yeah, we'll go from 4 to 5, 5 to 6, 6 to 7. 1, 2, 3. The distance between 4 and 7 is 3. 7, take away 4, it's going to give me a distance of 3. Does that make sense?
Yes.
Kinda? So this idea of this distance between numbers, it'll work with big numbers too. So let's make another subtraction number line. And this time we're going to do 243 minus 87. Yes. This time, these are going to be our endpoints. So I'm actually going to start, even though it feels kind of weird because my first number is 243, I'm actually going to start with the number 87. Because that's my smallest number. And I know that number lines go smallest to largest. And then my endpoint is going to be 243. Now, again, subtraction is that distance. how far away, how many jumps do I have to do to get to 243 from 87? Now, is it as simple as doing 1, 2, 3? No. But we've practiced making large jumps. So let's talk about what would be a friendly number that I can jump to from 87. So I'm jumping to the next friendly number. What is that going to be? Emma, what do you think?
10.
10? 87? 10?
20.
Is 20 going to be after 87?
90.
90 is the next friendly number that I can think of. So I'm going to make 90 on my number line. And then I'm going to do my jump from 87 to 90. How far away was that jump to get from 87 to 90? How far away was that? Miranda? 3. So far I've gone 3 spaces. What's going to be my next friendly number? Scarlett, what do you think? I think 102 because then I'll be able to do another big jump once I get to 100. So I'm going to make another tick mark for 100. And now I've gone 90 to 100. How far was that? Dominic? 10. So far I did a jump of 3, and then a jump of 10. What could be my next jump? Remember, my end goal is getting to 243. I'm at 100. Adrian, what do you think?
200.
I think I'm going to jump all the way to 200 because that's an easy number. Whee! Now I'm at 200. How far was that jump? Brinley? It was a distance of 100. So I've gone a distance of 3, and then a distance of 10, and then a distance of 100. Am I at my end point yet? I'm close, but I'm not there yet. How far do I need to go? Ethan?
You have to jump 4 more 10s and then 3 1s.
So because all I have to do is get to my end number from here, I can go ahead and make this a weird jump.
Like a 40 jump?
Like a 43 jump.
Oh.
So from 200 to 243, my last jump, even though that's not a super friendly number, I already made it to the end. It doesn't have to be a super friendly number. Well, now, what I need to do to figure out the distance, how far I jumped, I need to add up all my jumps. So let's write that down. I went a jump of 3, a jump of 10, a jump of 100, and a jump of 43.
Oh.
Write this down, please. So if I add in my ones column, I have 3 plus 0 plus 0 plus 3.
6.
That's going to give me a total of 6. If I look in my tens column, I have 1 10, 0 10s, 4 10s. How many tens is that?
5.
It's going to be 5 10s. And then I have 0 hundreds, 100, and 100. I mean 0 hundreds, 100, and 0 hundreds. Adrian? We're in the hundreds. Eliana? Just 100. The distance in between 87 and 243 is 156. That tells me that when I subtract this, I'm going to get 156.
That's the other part.
That is the other part. That's the distance between those numbers.
So if you add 87 and 156, you would get 242.
Yep. So far, so good? All right, let's keep going. So we just talked about this. It says that the answer to a subtraction problem is called the difference. It's called that because I'm measuring the difference between the two numbers, the distance in between. We already wrote this down. Does that make sense? It's a little tricky to think about. So now let's look at subtraction on a bar model. This is getting to where Easton's talking about wholes and parts. So go ahead and draw a bar model. Above it, I want you to write the equation 35 minus 4. Now we know when we're doing a bar model, I start with the whole, aka the total at the bottom. With subtraction, I know the total amount of stuff. Whatever it is you're counting lunch boxes, you're counting cupcakes, you're counting puppies. To subtract, you have to know the total. That number is your first number because that's what you have to start with. I want you to write a W over top of the number 35. That first number is always your total. It will not always be the biggest number. It will be in 3rd grade, but eventually you'll learn how to work with negative numbers. Negative numbers are numbers that are less than 0. Like -1. Eventually, you'll work with those. So don't think, oh, biggest number. No. It's no, it's not the smallest. No, that's not what I'm talking about. It is the whole, the total. So 35, since we just wrote a W above it, we need to put it where the whole or total normally goes, which is down here.
And we only have one other.
That means the other portions of my equation are both parts. Here's a part. Here's a part. So 4 is a part. And question mark is a part. Those are my 2 parts. How do I show a part on a bar model? Adria? Yeah, I just give it a little box, and then I put the number in. What's up?